and good afternoon to everyone else who's joining us for this IoT Alliance webinar. We'll just wait, say, a minute or so as more people join in, and then we will get going. So welcome everybody. It looks like we have 30 plus people who have joined us already, so thank you very much for that. What I'll do first of all is just give you a very brief introduction to the IoT Alliance. So IoT Alliance represents the NZ industry who have got interests in Internet of Things topics, and we have a role to provide knowledge and share knowledge and expertise from our members into kind of the wider industry and public, and with an overall purpose of generating economic growth. And I also like to add in brackets and social well-being with that as well, because if we're not doing good for the country, then generating dollars all by it alone isn't really sufficient. So let's keep a social purpose to what we do as well. So IoT Alliance represents a very broad group of participants. So that includes solution developers, platform providers, government agencies, researchers, service providers, and users and customers of IoT applications. So there's a very broad base of membership that collaborate and help each other out. And, you know, obviously, like mediums like this, help explain the purpose of what we're doing and, I say, popularize the benefits of IoT solutions. I also want to mention, if you want to keep up with what we do, register on the IoT Alliance website. We send out a monthly regular newsletter, and we're also on Twitter and LinkedIn if you wish to follow us there. So I will, without further ado, hand over to our presenters. So in order, we're going to have Ulrich Furk from Adroit First, followed by Matt Hector Taylor from IoT Ventures, and then Paul Oliver from IoT Taranaki. So Ulrich, are you keen to go?
Hi there, mate. My name is Ulrich Furk, and I am the founder and the director of Adroit. We're an IT company. We've been around we're in our 7th year of business now. So we are the distributors in New Zealand for Libellium, as well as Nettop and another brand called Dragino, as well as a producer of IoT hardware. We design and build and manufacture locally here, IoT things. We've been recently developed a piece of kit for traffic light infrastructure called BSmart, which interfaces blind, vision impaired people into traffic light infrastructure using Bluetooth beacons. We predominantly roll out now using NB-IoT Cat-M1, although we do use a little bit of LoRaWAN stuff as well. We are New Zealand. We're a global distributor for the Vodafone GDSP. So we, we design and build our solutions around, being able to sell it globally with our platform. We have a platform vendor that we've chosen out of Europe that's got a vast experience in terms of IoT platforms. They've rolled stuff out for the Netherlands Post, the Australian Postal Service, and a few others. And we've now rolled it out through Amazon Web Services on the back of IoT Core. So we design and build IoT solutions end to end. What I kind of wanted to kind of talk about in the Internet of Things in my short space is the idea of how many failures there are within the industry. If you consider Cisco released an article last year in regards to Internet of Things having a 70% failure rate. And so we've been doing a lot of kind of, looking at the products that we've been building and designing, and what things don't move away from pilots, what things, don't work and what things do work. So for example, bin sensors are an amazing IoT device, but what business case does it actually change for the businesses or the individuals? So for example, we're working with a company called Civic Contractors, and these guys rolled out, 100 or 200 bin sensors, and they wasted in their terms, they, put a whole lot of money into these sensors and this technology, but then it never changed their routes. It didn't optimize. It didn't actually change anything about their business. They just did it because it had the term IoT in it, rather than actually finding the right business case in order to do something. So if we look at it from this perspective, IoT should be about harmonizing the way humans and machines connect. IoT is enabling technology. It's not a market. It allows us to, take existing, sensors and existing equipment that exists, and make it smarter and put it on the internet. So it's live. So the information is coming to you live on the fly when you need it. And that can really help a business grow. That can really help a business, solve any problems around alerting or anything like that. So, I just wanted to kind of, talk about, some of you may or may not have heard of Rio Tinto, but in terms of, success story, that this company jumped onto understanding what IoT was from day one. And they only roll stuff out that actually has some kind of business driver as to why IoT should be rolled out. So what they've done, in a really simple form, is they've used an accelerometer inside of a truck to measure vibration on the road. And then they have a simple little green and red light that pushes, sorry guys, let me see. Hey guys, hey, sorry, can you just keep going? Sorry. And so they measure all the vibration and stuff in there, and then they direct people around the roads where there's sort of issues with roads and potholes and stuff that deteriorates the tires. Because a set of these tires on these trucks is something like $1 million for a set of tires. So if they can make the tires last 20, 30, 40% longer because they're directing the trucks around each pothole and each kind of issue within the mine, they can save an absolute fortune. So they actually found a business case that was the main driver for them to be able to spend the money to actually roll out a really good IoT solution, something that really, really works. So what this does is it's a very much an edge-driven device. So not only is it internet connected and it's getting all the machine learning and algorithms from the Amazon IoT core, it's also edge-driven using Amazon Greengrass. So as the truck comes out of network coverage and goes down deep into the mine and then comes back out, it already has all its learning capabilities already done. When it gets up top, it uploads some new data which gets analyzed, and they've really worked out a way to really use IoT to its most extent. So last year, 2019, these guys, by implementing IoT, saved $19 million in just tire use. So there's some really cool facts and stuff around this kind of stuff. Again, if you've got any questions, feel free to ask away. Like if you look at smart cities, from our perspective, smart cities are really important to us, especially now post COVID in New Zealand. How can we really make the Internet of Things a part of a city, and making a city efficient, make a business efficient, is obviously one key thing. And that comes around things like, security, IoT cameras, for example, being able to do people counts and understand how people congregate within certain areas. This information can be used to roll out better city infrastructure, for example. So the need to have more toilets, or the need to have more parks for people, instead of a city planner sitting down with an Excel spreadsheet and writing down some fictitious numbers. That's all theory. A city planner can now get some real data and really understand, how people are using the Wynyard Quarter, for example, how they're using the actual environment. That can also, be filled in by, counting using Bluetooth people scanners, for example. So, we have a range of Labellium people scanners that uses Bluetooth and Wi-Fi connectivity to count the amount of people and understand the flow of how someone walks from one area to another area. And there's some other fun kind of, game kind of gamification that could be, you know, brought into a smart city that can make it not just work for the city planners, but also the people involved in the process. So, for example, the council have all these new beautiful pathways that they've rolled out through Auckland City. They've got a few hundred of them, and they're like, well, how can we make people use them more? What can IoT do to actually enhance someone's enjoyment? You know, and that's where you can sort of gamify the path. So you can now time someone's phone from point A to point B, and then you can put them up on a scoreboard, and, you know, it can really fill in some really cool gaps. So it can give it, you know, the city planners the right information that they require, and then it can also be brought down and still be used for those fun kind of aspects of what IoT can do. You know, down from connected cars, you know, IoT, we've seen companies like Fleur coming out with some really amazing technology, you know, that can see a car driving down the road from a kilometre away. You know, that information can then be used to trigger, you know, different events happening, changing light phases and that kind of stuff, which again, you know, is really important for a smart city. When you drive through Singapore, you know, a car coming is seeing the lights are automatically changing, and the traffic in the city is nearly negligent. There's hardly any traffic in Singapore City anymore because they're using IoT and AI around making it really smart. You know, it's learning for itself. You know, and then there's, you know, kind of, you know, things around, say, public transport. Well, public transport's an issue, you know, whereas we're having to make all these bus lanes and all these things to make our public transport more efficient. So, you know, bringing in IoT and the traffic cameras and the traffic technology and even the Bluetooth scanners, they can now plan their routes differently, or they can plan certain things to really, you know, drive change to make the public transport more efficient and more affordable. And, you know, that can really, you know, drive a smart city to be truly smart. You know, and then you've got, you know, other things that we can, you know, talk about where, you know, all of a sudden we can measure the water quality of the beaches and the water quality of the environments and the air quality, and it becomes live. So instead of it being a guy turning up with a jar, I've got a jar on my desk here, filling some water in the jar, taking it to a lab, that whole process takes time. So actually, that's quite a cool story. I'll fill this one in on. So with Auckland beaches, they currently use that jar, they take it to a lab, and then they fill the previous information they got from the lab and the weather data into a model. And that model then detects when the beaches are unsafe to swim or not. But the problem is, again, it's theoretical. It's not real data. So all of a sudden, you know, the IoT Reach, you can put a battery-operated, solar-powered device connected to NB-IoT. You can float it in the buoy in the middle of the harbour, and it can measure live data and give you the information to fill in those gaps so that the model becomes more accurate. And all of a sudden, the beach that may not be safe to swim in is actually safe to swim in, or the beach that is safe to swim in is actually not safe to swim in. So the information can be really useful in the process.
All right, just 2 more minutes, please.
Sure, no worries. You know, so I guess from our perspective, we've been rolling out quite a few smart city projects. We've got you know, air quality meters rolled out through a few places like Ponsonby Central, for example, and the information's been really useful for those people to really make kind of changes within their organizations. Like in terms of like failures for us, you know, network connectivity has been a really difficult thing for us. You know, and now we've gone down the path of NB-IoT Cat-M1, which seems to have definitely solved that. It's the access to the networks that are really important to us, and you know, connecting to people's local networks, or connecting into your Wi-Fi connectivity or anything like that. You know, just kind of causes quite a lot of kind of issue getting the data and streaming the data. And, you know, we've now learnt, you know, by putting it on a really stable system like NB-IoT Cat-M1, you know, we can deploy things. We've had sensors deployed in the field now for 3 to 6 months, and we don't even have to go there and restart them or turn them off. They just run, and the data streams to our platform. So yeah, from our perspective, I guess our biggest learn has definitely been choosing the right connectivity for the right thing. You know, if it's a metering process, go down a LoRaWAN perspective. If it's a big sensor bit of data, go down a CAD path. You know, that's been our really big learns.
Thanks a lot, Ulrich. That's really interesting. And yeah, those comments about connectivity and platform solutions, it's good to hear.
Sure.
I'm now going to hand over to Matt from
Sure.
IoT Ventures. Matt, can you just confirm, am I actually sharing my screen correctly?
Yeah, that's good.
All right.
Perfect. Thank you. Hey, everyone. My name is Matt Hector Taylor. I'm a founder and kind of director of IoT Ventures. And similar to Adroit, we are a kind of a end-to-end IoT solution provider. But we focus very much on the LoRaWAN end of the scale and kind of specialize in LoRaWAN rather than other network technologies. We do have another thing in common, which was we think that the business problem is the way that you need to start. So I'm going to focus on a single business problem to start off with that we've been working on, and just kind of take you through our kind of experience of doing that, delivering against this particular problem. So if we can go to the next slide, John. So basically, we don't start any work until we're really clear that there's a problem that needs to be solved and that there's a few people that care enough about it, and that the technology can deliver an outcome at the right price point to make it worthwhile solving. So in this case, if you're watering a park or a sports field or a botanical garden or a farm or an orchard or a green area, that's a large area, you know, manual control systems, sprinkler control systems either take a lot of effort to control watering, particularly if weather conditions change, or you need to start kind of reporting on your water use and kind of operating within a regulatory kind of framework. And in some areas, there's good coverage from 3G, 4G, LTE, but in many areas there's not. And so actually taking the manual labour out of looking after irrigation is often not kind of technically feasible. So what people are looking for is a kind of an end-to-end solution. So if we go on to the next one. And so, you know, we've worked with a group of customers to develop a solution that's about irrigation control. So controlling long-range water usage from a mobile device or a control centre, monitoring weather conditions and soil moisture wirelessly and remotely to inform kind of the operational decisions that you're going to make. That enables you to respond proactively to issues and to also to undertake predictive maintenance. So a lot of the savings are in not actually having to go out into the field to randomly maintain things or fix things, and also being able to start to demonstrate water leadership. And, you know, we're all familiar with the sort of drought that Northland and Auckland and other parts of New Zealand are having. So water usage is going to become a bigger and bigger sort of problem. So if we go to the next one, this is a sort of pretty standard architecture for an IoT solution. On the left-hand side, we have a number of kind of devices that are attached to things. In this case, the things are sprinklers. They're transmitting some information about their sprinkler, about whether it's operating, kind of how kind of much battery power it's got left, what its signal strength is, and it's kind of transmitting that information over multiple kilometres via either a public network or a private network, or we've even put in a complete offline network to a back-end solution that is available kind of on a mobile phone or a mobile device. Again, we build on AWS, but have kind of built a sort of an application framework, because what we're trying to do here is actually leverage the bidirectional capability and use the back end to program hundreds of irrigation devices with a pre-programmed pattern, which can then, with a flick of a kind of of a mouse and a click, that if the wind is blowing strongly to the west and then it turns around to the east, that you can kind of reorder your programs. If it starts raining and you need to stop, if you want to fertilize something and not have it kind of then run into the drains, that you can turn your all of your sprinklers on or off. And it sounds like quite a narrow set of use cases, but there are a lot of people that are employed spending quite a lot of time that do this job manually, and so being able to automate it is quite a big deal. So that's required. If we go on to the next one, we have a back-end solution. And there's a lot of frameworks that are out there for displaying data, and we've really backed away from them. We don't feel that they help you particularly develop something that suits your use case. And in this case, a council or a large property owner or somebody that's responsible for botanical gardens or regional parks or any of those things has got multiple parks. They need to be able to set up properties. They need to be able to set up zones. They need to be able to identify their irrigators. They need to then be able to program them down to the individual irrigator, and need to be able to model out kind of the water usage based on kind of pipe pressure, pump control, and a range of other kind of factors. And then they also need to be able to see when they need to get out of the car and come and drive out. And in some cases, these irrigators might be spread over several kilometres. And so it's actually not a small job to go out and check them one by one. So getting an individual notification that sprinkler number 1057 actually has an issue and is not working is a lot more helpful than going around every 3 months and checking every single one when 99% of them are good. So on the other end is the actual device itself. And so Ulrich talked a little bit about kind of solar power. If we go to the next one, John. Yeah. So these are designed and built. We've created these to last in the field for more than 10 years without a battery change. And so these are controllers, so they work both ways. They send an uplink message, what kind of program they've got program, how well they are when they last ran. We've got some accelerometer data in there so that we can actually measure that they were working, and they're controlling a solenoid, so we understand kind of if the electric circuit is broken. So there's a number of error messages that we can produce from the device, and obviously we can take a downlink which has a series of commands about when the device should start and stop, the irrigator that it's attached to. And you can see on the right hand side my little joke about IoT in the field. So someone obviously putting some IoT in the field. So for us, the next slide, we had to go from not knowing very much about irrigation. If you go to the next one, John. And no, the one before, I think.
Is that right?
Yeah, that's it. And so basically we didn't know a huge amount, and our customers, they were pretty desperate for a solution because we were good at IoT, but really, naive about water management. But for them, they could see the benefits, and there was a real kind of drive for the solution. And as soon as we got it in and working, we immediately changed their paradigm. So they could see their workload being reduced, and the kind of quality and the service offering that they were going to be able to deliver just go through the roof. So that was great. We delivered some benefits straight away. We had some challenges with reliability. It was kind of quite a lot of learning, deploying these out remotely over quite a large distance. But over a reasonably quick period of time, we built that kind of confidence up that these devices will work and work and work in any weather condition and won't need continuous maintenance. And another key thing, of course, was about responsiveness. That if we would be able to go down and fix it. But also, and this is a kind of one of the characteristics of LoRaWAN. This is a control solution, and most people, if you push a control button, you expect the thing that you're controlling to turn on straight away. But in the case of LoRaWAN, there could be a lag of about 30 minutes for a round trip. And so building up that confidence in the customer and about a different way of working is quite a big change to get on top of. And at the end of that, if you can deliver benefits and reliability and responsiveness, then you get trust, and that's quite a big deal. So for us, kind of pedaling away behind the scenes, we had to very quickly work out what the back end needed to be, and spent quite a bit of time making a bad user experience to start off with about how to program these individual sprinklers. And in the end, we've got to a fantastically clever way of doing it once we've got enough sort of feedback from users. But if you're, it does show that subject matter expertise and domain expertise is really good. Is an important kind of part of a successful implementation. Network availability, as Ulrich says, is a major. And then if you've got availability, coverage is another thing. So just because a network is there and it shows that it's there on a website, it doesn't necessarily mean it's there at the bottom of a gully or there behind that particular building. It's just kind of there on a broad kind of map. And so being able to deal with coverage is quite a big deal. Devices, testing is really critical. You can't say how important it is to test and test and test before you put your devices in the field, particularly with LoRaWAN. Over-the-air upgrades are not kind of feasible yet. I mean, there's quite a lot of stuff that you can configure, but the actual firmware upgrades, so if you're going and having to fix firmware in the field, it can get pretty expensive. And similarly, remote monitoring, diagnosis and support. If you're supporting thousands of devices spread over hundreds of kilometres with different customers, and you need to know when a base station has gone down or when a device is not communicating, then that's kind of quite an important thing to have baked into your business model. So the next thing that's kind of pretty important to have in your business model is actually distributors. So if we go to the next one, John.
Yeah, just a couple more minutes there, please, Matt.
Yeah, we're near the end. So basically, we've been able to find a path to market in New Zealand. And at the stage now where we're ready to start exporting the solution to Australia kind of in spring and summer. We've had a few kind of inbound inquiries, and we're sort of gearing up for that. So if we go to the kind of conclusion, I mean, basically, from our point of view, we think there's a lot of opportunity within the smart city space. There's a lot more to do with water, residential use, industrial use, kind of agricultural use, wastewater, parking. We're doing work in social housing and aged care. We're doing some work in the workplace and workforce safety space, buildings in the built environment, and kind of location and tracking. And so I guess what we've found, I mean, we haven't been going as long as Adroit. We started in 2015, so about 5 years now, is that the technology and the capability to actually deliver benefits at scale is really here now. I mean, it's not saying that it's easy, but it's certainly proven and doable, and that the price benefits are, quite massive if you get your business case and your business problem right. So I'll stop there.
Right, thanks a lot, Matt. That's quite interesting. I can see some questions coming into my own head, let alone from anyone else. So it'd be interesting to see if anything else pops up around that. I think there's a message overall, I think, from all of this today that we want to underline is about, solution developers and platform providers are kind of past the point of doing POCs and trial systems. They are now, being deployed widespread and scaling up. And it's really about demonstrating the business benefits. And I think Matt's point has underlined that. So Paul, we'll hand over onto you next, and I think I've got some pictures of yours to share.
Yep, thank you. Good afternoon, everybody. I'm Paul Oliver from IoT Taranaki, in Taranaki, naturally. Now, as the other participants have mentioned, both of them, one of the problems is network coverage. So that's the area which I'll be dealing with in my little ramble. So we started in about the end of 2016, beginning of 2017. We actually didn't really start off with the intent of building a network. We started down the track of developing a product to do with water, and fairly quickly realized that getting that information to where it's needing to go was going to prove to be a problem, because where the information was being gathered from potentially was quite remote. So we started to look around for a solution to that, and low-RA WAN and low-RA radios had fairly recently been commercialized, and we saw that as the way to go. So we started off down the track of setting up a network in the Taranaki region. So we started putting up a couple of gateways. This one here, you can see, is our first gateway. And as you can see, it's sitting in amongst a whole lot of other gear. And the reason behind that was we needed a method of, putting them up fairly high with a commercial grade backbone back to our server, and continuous power, the whole thing. And the logical conclusion and the logical way forward that we came up with was approach the local wireless internet service provider down here, which is Primo Wireless, and Matt Harrison at Primo agreed. He could see the potential for IoT even in that early stage, and with some very generous terms from Matt, he agreed to put our gateways up on the towers wherever we wanted them to go. So how do you determine where they need to go? Well, you need to get a large input. You need to have lots of sensors out there to get a good idea of how the coverage is actually working. So you put in some seed gateways, see what's coming back, and start deploying from that point. Now, to achieve this, we needed to have a customer that has lots of network, lots of nodes out there. And by luck, if you like to call it, or serendipity, the predator-free initiative had been announced in the Taranaki region around about the same time. So we approached the Taranaki Regional Council, put a proposal to them, and they accepted it. As a result of that, the Taranaki Regional Council and the Predator-Free initiative started deploying nodes on traps. These nodes were supplied by a company in New Zealand called EcoNode, and this is an example of one of them here. That's sitting inside a dock possum trap. These nodes will also fit inside rat traps and a few other bits and a few other types of traps. So effectively, when the trap is sprung, there's a magnet which tells the node that it has done so. That information is then sent away to Traps NZ, and then is displayed on a map with a pulsing circle, basically, which says either the trap is sprung or it's not. So the upshot of that is, pretty obvious. You then don't, if your traps are enabled with these nodes, you don't have to go and check them out every day. You can have a look at your map and say, okay, that one's sprung, I'll go and have a look at that. Saves a lot of time and moving around the place. Now, the problem with these is, and we unfortunately did, well, not unfortunately, I think it's fortunate, we picked a use case where the nodes are probably the worst scenario for picking up LoRaWAN. The aerial is internal. It's a small helicoidal aerial. So we had to carefully monitor what was coming in and then start making decisions on deploying other gateways. So the methodology of looking at what's coming in and making decisions on where the other gateways go did work. So we are now deployed 14 gateways. I think we've got it up at the moment around Taranaki. And so this is working quite well. The upshot of this, of course, is it's not just there for the Taranaki Regional Council. We are enabling the whole of the Taranaki region with LoRaWAN. And there are other use cases now starting to come up. So we are now starting into trials with the hydrology department in the Taranaki Regional Council. There is a new national policy statement out on water, and some of the requirements within that, people must start monitoring their uptake. So, water, that's what that would be, but because it's fluids, the Regional Council and the hydrologists also monitor effluent for compliance from farmers. So we are starting down the track of finding solutions to do exactly that. The reason being is that on a effluent spreader, for instance, if it is a consented spreader, it does require a sensor and a radio unit, and these units that they're putting out on these fertilizer spreaders can cost up to $2,000 or $3,000, plus a monthly fee for the cellular backhaul. So we are working on that with the hydrologists as well. And the other businesses now within Taranaki, particularly within the water area, are starting to show interest in trials as well. We fortunately have a collaboration starting up with a company down here that is actually the blue tick certified calibrator, one of two in the region. What that means is if our solution comes up to blue tick standard, then the data that is gathered can be regarded as true and accurate. That's a big deal because a lot of the country's water uptake is actually currently based on the number that appears on a consent as opposed to what is actually happening. So, LoRaWAN is definitely the way to go because of the remoteness of some of these areas, and we're carrying on with that. This particular picture that you can see now is actually sitting on top of the chimney at Port Taranaki. So it's a couple of 100 meters up in the air, giving us very good coverage. So basically we, as opposed to the other folks on this presentation, we provide the network. And we do see this as a potential model for other regions to deploy. Our deployment scenario is as close to 100% geographical coverage as opposed to population-based coverage within our region. And, you know, if you get the geographical coverage, you get people able to use this technology for stuff that they've never even thought that they could use it to make their job simpler, like an irrigation spreader heading off down a paddock. An effluent spreader heading off down a paddock. If it stops, it pools. So, and that's not good because, you know, it'll run off and go into a stream. So, you know, if a farmer can be alerted that his effluent spreader has stopped and turn the pump off, he's saved himself potentially a lot of problem. So, further to these gateways that we're using, as you can see, that particular one's a multi-tech. They're all IP67 rated outdoor gateways. We are using other gateways as well. And it's not just nodes and gateways. Obviously, it also is a server. We run our own servers. We have redundancy. We've got one in Palmerston North and one in a server room in New Plymouth. And the server software that we're running is open source, so that we can, you know, we can provide and redirect wherever we want. We're currently redirecting some stuff for Matt down here as a trial. So apart from network provision, we will also be acting as an integrator. We will be collaborating with people like IoT Ventures to, you know, provide a network for them and also a means of distributing their nodes down here.
Hey, thanks, Paul. Now, I'm just going to hand over to Jeanette Macbull, who's joined us. So Jeanette, do you want to say a couple of words, and
Yep.
we can then go through some of those questions?
Hey guys, so I'm joining the session today to moderate the Q&A. Hello Matt, hello Ulrich and Paul. Paul, you and I have never met in person, but we've spoken on the phone.
Yeah,
So yeah, we've got obviously some questions that have come through the chat, which John will continue to monitor. I'm a principal advisor in IoT and Agritech for Asia Pacific with Ecosystem, which is a technology research firm based out of Singapore, but also alongside John, I'm on the New Zealand IoT Alliance Executive Council. And thank you for joining us for today's event. So obviously tons of information being shared, which is amazing. And I know these guys, I know the stuff that they are actually working on. So really cool to hear about it and to be able to share that with the audience. So as a start, so we've got some questions to get the sort of conversation underway. Firstly, let's think about actual applications and what we've heard about a number of applications today, but wondering what your thoughts are, and I will pick somebody to go first on whether when building and designing or designing and building an application, you're thinking of, and whether we should be thinking of single use or whether we should be thinking of solutions that are actually more appropriate to a number of use cases. Where do you land, and what is your opinion on that in terms of innovation in this space? Please, Paul.
Oh, right. Okay. We're not heavily involved in the development of nodes, etc. But actually, the concept of multiple use already exists. I mean, if you have a look at a thing that will measure pulses, for instance, you can measure a water meter with that. You can measure a weather vane with that. You can measure the rotation of a drive shaft with that. Mm-hmm. So, you know, if you know, that's just a subset of other stuff that you can measure with pulses. So, you know, it really multiple use cases dependent, I think, on, you know, people's imagination, basically. You can have a look at some of the tools that are already available and adapt them to what you want them to measure.
Great. Anyone else?
Yeah, look, I mean, it depends on I guess, on the application as well that you have. Like, for example, we're integrating with, water quality sensors that can cost up to 60 grand for a sensor. It's a full spectrum sensor, so we can pretty much do anything, but there's a lot of development work in getting the information from the sensor and knowing what measures, say, nitrate and what measures turbidity and what measures pH. And so yeah, in theory, the sensors and the equipment can be, definitely developed for multi-use, but in some cases, you have to build a specific use case and solve that use case really, really well. And then if a second use case comes along, you can reuse some of the tech that's there, but you might need to rewrite some of the code or how the code comes down. So for example, air quality indexing has to be done on a rolling average over a 1 in 24-hour period, where indoor air quality has to be done on a rolling average of 1 hour, where CO2 is live. So even though it's the same sensors and the same equipment, the way that it's programmed and works is slightly different, and can have different outputs. You might have to add 2 sensor values together to get one thing. So yes, I mean it depends on what the need is. Again, coming back to the need, you need to know what you're trying to achieve.
What about you, Matt?
I'd say if you were in a room with 1,000 beer bottles and somebody gave you a Swiss Army knife, you would lose if somebody gave you a bottle opener. So it just depends. I think once you're doing things in production, that you need to be focused on the use case. But if you're testing, if you're at an early stage where you're trying to work out what works, then having a kind of reusable platform kind of makes sense.
Okay. Yep. And I think I've heard you use that before.
I have. It's a big deal for us. Kind of like there's a lot of Swiss Army knife devices out there, so everybody will tell you something that can do everything.
And I knew you'd have something to say.
We've
got a technical question actually, so I might take one from the list. And I don't know the answer to this one, but it might be really simple. What's the maximum speed of a LoRaWAN network, and are there any data limitations?
Paul can answer that one.
Maximum speed. Well, I think it's 5. Sorry, I can't give you that. But data limitations can be determined by the channel plan of a particular country, say, that you're in. So you may have a thing called a duty cycle limit, which basically means that you can only transmit for a certain percentage of an hour. What you can actually then fit into that and what speed it's actually going at will determine how long you need to stay on air for and how much data that you can get within that duty cycle.
So do your homework, basically.
It's pretty small. I mean,
it's pretty small.
It's 35 bytes every sort of 6 minutes as a Class C device in New Zealand.
All right.
So not a lot.
So I hope that answers. I hope that answers the question from Adrian. So another question that I have, and we've heard a couple of you mentioned a couple of times rather, platforms. And if I hear of someone else bringing out a whole other new platform for IoT, I'm just going to scream. But what are your thoughts on a platform? So there are a number of platforms out there around IoT. What does a platform have to deliver? Most importantly, so if you had the money and probably the technical nous and I guess the buy-in from stakeholders, what would a dream IoT platform look like? Ulrich, if you want to kick that off.
Sure, thanks. Just to give you guys a little bit of kind of understanding, obviously when I started Adroit, I actually started off with the intent of building my own platform. And after many years of working and spending lots of money and not actually finishing the platform, we scoured the earth. We traveled the earth. I went to Singapore and I went to Europe, and I kind of met some of the leaders in the IoT kind of field overseas, and we stumbled upon a really amazing platform called Walkabout, made by a really large company. They've got 250 staff. They specialize in just platform. That's all they do. And it's tried and tested. So, I think what's really important is stability and a platform that's super tried and tested. So we've actually deployed that ourselves now. So the Adroit platform launched about 6 months ago with on the back of an amazing platform called Walkabout. And I guess the biggest thing for us is the fact that it needs to, be device management It needs to look after the device. It needs to look after the data that's in it. Be able to do simple calculations inside the platform, offer really simple, basic dashboarding and reporting and alerting, and then provide a really comprehensive API that you can give to an application developer who can then go and write their own application on top of that. So, for example, we're about to roll out for some shrimp farms the ability for them. They've made an application that's specifically around shrimp farming. They just take the data stream from our platform. So, from our perspective, it needs to be device management, data management. It needs to be really simple and easy to use. It needs to have simple alerting and reporting and a really comprehensive API.
Right. Matt, your thoughts?
Pretty similar, really. It's about I think it's one thing to build an IoT solution. It's a totally different thing to operate it. And so being able to manage devices, be able to monitor what's going on in the field, what's happening with the devices is pretty key. And being able to then create a flexible application that on top of whatever the platform is. But the thing with IoT is it's just a series of platforms, and it's all platforms on platforms. It's like a layer cake. I mean, everything's built on AWS or Azure or whatever, which is a platform. LoRaWAN standard, kind of LoRaWAN network, that's a platform. Kind of the firmware on your chips is a platform, again, that's built on another platform. So by the time that you are putting these things together, you're actually managing multiple platforms. And then just the one thing to worry about is if you're doing everything on a platform, how much of the IP is yours?
Yep. So there are a number of considerations. I was on an agri-tech panel the other day, and we were talking about that whole issue of platforms on platforms and devices and how a farmer, what does that look like to a farmer, being able to manage their farm. So do you have anything to add to that conversation, Paul?
Yeah, I mean, I'm biased naturally to LoRaWAN, and I mean, there's been discussions about potentially some sort of nationwide LoRaWAN network. I mean, I know Spark has got one, but it's not geographically covered, and and it needs to be. There's no doubt about that. If you actually want to get this capability out to a farm, you have to have geographical coverage. Otherwise, it's just not going to work. So, let's assume a LoRaWAN solution is rolled out countrywide based on something like what we're doing here. The back end would have to be the same countrywide. And by default, then anybody that wants to add a solution to that knows exactly what they have to do so. Within that, you've got folks, creating their own applications. That's great. But there is also the capability of firing it, as in the case of the shrimp farm. We're going to be firing water meter data straight into the regional council's database without having to go through an application, because some clients will actually just require raw data and they can do the analytics themselves. Yep. So, that would be my ultimate. A nationwide LoRaWAN network, and I know there's other people on this panel who think the same way, would be the way to go.
Brilliant.
Particularly for remote geographical coverage.
Brilliant. Let's hope, fingers crossed, eh? We've got another one from the audience, and we've got a couple of about a minute or so to quickly sort of answer this one. So, do all business requirements have high sensitivity on timing, latency, and other parameters? Does that make sense to anyone?
I think the answer is that everybody's a bit different. Like if you are doing a life kind of saving service like emergency care, you aren't going to want the sort of latency that you have in a LoRaWAN network. In the same way, if you're going to have a self-driving car, 35 kind of bytes every 6 or 15 minutes is not really going to cut it. But if you're kind kind of measuring water in a tank that's 15 kilometres away from where you actually are, and it's rarely used, then sending a tiny little kind of message once every hour is not a problem. So it's kind of, it goes right back to what's the business problem that you're trying to solve, and then what's your technology choice and your kind of commercial choice that you're going to make. What can you afford to have in terms of latency?
Great.
You do need,
keep going.
Part of this, you do need to sit down with your potential client to, to establish exactly what Matt was saying. They may say, oh, LoRaWAN, let's use that because it's cheap or whatever, it's easily available. But it actually may be the wrong thing for what they want to achieve. And, there is definitely, LoRaWAN and NB-IoT, they have got to be able to coexist and, seed each other, help each other out, whatever, for this whole IoT thing to work. It shouldn't be we shouldn't be trying to separate it out at all. We should, the stuff with low latency and the stuff with high latency, both provide different solutions to people.
Fantastic. Hey, that's all we've got really time for in terms of the formal session. Thanks everybody for attending, and it has been recorded and John will be sharing it out. If anybody wants to hang around, I think we're okay to sort of have a couple of other extra Q&A, a few more minutes of Q&A if anyone wants to hang around, but anyone that's signing off now, thank you for joining us. And here's a question that's just come straight through.
I just have something to add on.
All right, sorry, Ulrich.
Hi. Being the Labellium distributors as well as the NetOp distributors, all the devices that we can buy and use as a part of a solution are available in, a multitude of different applications. So in some cases, LoRaWAN is the best network to choose. In other cases, Cat-M1 is. In other cases, NB-IoT is. We're looking at a fridge sense at the moment inside of big Faraday cages, that are just solid steel. NB-IoT is the only network coverage that we can get inside of those fridges.
Yeah.
But then in some cases, you might need to look at a Bluetooth solution, depending on what's required in the process. So yeah, absolutely pick how you're going to get your data based on what it is you're trying to achieve. There's no point in rolling out a water sensor on Cat-M1 when LoRaWAN will do it better than Cat-M1 will. So it's picking the right thing for the right thing.
And that sounds really simple, doesn't it? But actually, when you're there and you're in the midst of trying to provide a solution to a stakeholder, and that there's a time constraint or there's a monetary constraint, or you're trying to get something out, so then you can actually use that solution to piggyback off for other opportunities. You don't have the time sometimes. You don't have the time. You don't have the connections to be able to find all that out.
It's relatively, it's getting easier and easier and easier. So we have a Labellium plug-in sense that's made for air quality. The network layer module that goes inside, whether it's LoRaWAN, Cat-M1, NB-IoT, whatever, we just swap it out and upload the code. So it's not really a huge thing for us anymore. A year ago, absolutely, you had to put a lot more thought into it. But now, a network layer thing for us is relatively easy to pick and choose. And sometimes it's also down to the customer. They might have an existing relationship with Spark, or they might have an existing relationship with Vodafone, or they might have an existing relationship with someone else. We're trying to be agnostic in the process. So not only recommend the best network for the need, there's also a relationship that might need to be considered in the background as well.
That's a good point. So gets me on to my next question, which we'd pre-prepared, which is, if you're looking to innovate in this space, and we're talking about whether it's entrepreneurs coming up with the next biggest thing, whether it be councils, community organizations, small business, whoever. I mean, loads of stakeholders around the country are now on their digital journey, more so now since COVID. Who should they engage with? Do they go to vendors directly? Do we go through a consultant? Is it industry organizations, or should they focus, in fact, on building their own capability with, the announcement of a new program in IoT innovation from the Tech Futures Lab? I mean, what are your thoughts? Obviously, you've run your own businesses, two of you, but for the New Zealander wanting to innovate in IoT, so we can see some you know, some innovation, some ground roots innovation. What's your sort of advice?
I'm taking it from an investment perspective, or from a new kind of investment perspective. The most important thing is investors and other stakeholders invest in momentum. Excuse me. So what's really important is building your device and getting some traction and getting it in the field and getting it tested, and and each step will get you closer and closer and closer. There's some really great tools that you can start with if you're an entrepreneurial inventor that wants to make a device to do something. John McDermott and I go way back with PyCom. Obviously we've kind of moved away from PyCom and gone definitely down the Labellium Wasmo path, or the NetOp Lego box path. But we're in there are so many really good things that you can use, and you can start really cheaply, and you can do it in your spare time, and you can find some coders to kind of help you. And as you find that business case and you've solved the problem, and you've got a product that really, really works, then put it in the field and test it. And the more testing you have, and the more people and the more feedback you have, it's user-centric feedback. The more feedback you have coming from your customers, the better your product's going to be, right? So just drive it by listening. And then as you need to go through raising money and capital, the more momentum you have, the easier it is to get access to that capital. A bank won't give it to you, but there are a lot of really cool people out there, little kind of angels, flying Kiwi angels and stuff that can really help you grow.
Sweet, that's great. Anyone else want to add anything to that sort of?
Well, I think there's a need. We're all highly aware of IoT, but actually. The concept of IoT and how easy it is to actually, potentially, how it is to actually get involved in it, it may not be obvious to a huge proportion of the population. So, particularly the young folk. So, I think going down the track of some educational courses, maybe some NZQA qualifications, and some very basic IoT. Building something from an Arduino, let's say, to connecting to a local network, seeing a light turn on because they press a button on the other side of the room. That sort of stuff really sparks interest. So, if you start at that level, and then as they grow, as things progress, people will become aware of what it's actually capable of. Because I think I'm not 100% sure people actually are, apart from people heavily involved in it like we are.
Hey, Jenna, I'm just going to poke my finger in for a moment. And there was a question which came up, which I think is worth touching on, which was related to 5G. So I'll just make a very brief point about this. I think what's happening with 5G is actually kind of interesting, in that you can kind of look at what the telcos are saying about 5G from two perspectives. One is 5G as a technology and a new rollout of updates to cell towers to give more broadband and faster latency. The other is 5G as a almost like a solution brand. And what you kind of see is 5G is encompassing the broadband stuff, IoT, upgrades to 4G technology, and also the kind of the small data type LP-WAN type applications as well. So it's kind of interesting when you see discussion about 5G is actually think of it as a kind of a reboot of IoT use cases through telco networks.
I'm just going to add on to that one, John, because obviously we roll out. We've just finished our Vodafone GDSP, which took us 18 months to get there. IoT within in the LTE spectrum, takes a cell phone tower from a 5 kilometer radius, talking on your cell phone, to 120 kilometer radius. So all of a sudden, pockets where there's no cell phone coverage, you've got NB-IoT Cat-M1 coverage in the process. But just to clarify, NB-IoT Cat-M1 are two separate networks. Sometimes they go hand in hand. Most of the chipsets that we use are both NB-IoT Cat-M1 chipsets on the process. Because it's on LTE, LTE is the standard that's gone through from 3G to 4G and now to 5G. So in a nutshell, what 5G enables is further push into those areas and kind of a longer range connectivity with more throughput as well. So all of a sudden, an artificial intelligent camera that will only work in the Viaduct Harbour because it requires 4G coverage can now be placed at the end of the Fieldlands Harbour on a 5G NB-IoT connectivity and actually stream video over that connection live. So it just kind of gives you a lot more throughput in the process. A lot of it's still theoretical. And obviously we're only using NB-IoT Cat-M1 on the 4G network. We haven't switched, but our chipsets are already 5G enabled, so we can push them forward. But it just gives us, the potential for growth into those areas, like bringing more technology with more throughput requirements in more the bigger area space. Big sensors, full spectrum sensors, that kind of stuff can now go to places where they couldn't go before. They can now go.
Sweet. Shall we wrap up now, John? I think we've had
thanks very much, Jeanette, and
Matt had to go.
Thanks everyone else. Really appreciate you taking part today, and as I said, we'll share around the presentations and contact info for everyone as well.